Welcome to qnawire.
In this problem, we have a car that is about to go down on a inclined road. The distance of the inclined road is 12.8 meters and the angle of inclination of the road is 30 degrees. The initial speed of the car is 21.6 km per hour. It experiences a friction force with a coefficient of 1 over 2 multiplied by square root of 3. Now, the problem asks us to show that the final velocity of the car after reaching 12.8 meters on the inclined plane is 36 km per hour. So this problem involves kinematic equations and Newton's law of motion. First, we will draw the forces acting on the car. First, the weight points vertically downward, denoted as F sub W. Next, the force that is perpendicular to the inclined surface, we denote this as F sub N. This is the normal force exerted by the ground to the body of the car. And then the friction force pulling it upwards, opposite its movement, F sub K. In this case, it is kinetic friction force since the body is moving. Next, since it is lying on an angle, we have the weight acting on both directions. In this direction, the weight is pulling down the car by weight multiplied by the sine of the angle of inclination. In this direction, opposite the normal force, the weight is pulling the car by an angle of by a magnitude of weight multiplied by the cosine of the angle. Now we have the forces acting on the car. Let's separate it into x and y plane. So this is the y plane and this is the x plane. Let's start with the x plane. The y plane. Let's denote the summation of forces in this plane as F sub y. According to first law of motion, the summation of forces when a body is equilibrium is equal to 0. In this plane, the net force is 0 since the body is not moving in this direction. As such, 0 is equals to the summation of the forces on this plane, which is the normal force and the force due to the weight of the car, which is the weight multiplied by cosine theta, which is negative since opposite the normal force. We know that weight is equals to mass multiplied by the acceleration due to gravity. So we can rewrite this as negative mg cosine theta, or simply F sub n is equals to mg cosine theta. Now, for the x plane, the summation of the forces is not equal to 0 since the car is accelerating. As such, we will now apply second law of motion that states that force is a product of mass of the body and the acceleration due to its movement. We denote it as A sub x. So to prove that the final velocity is 36 km per hour, we will need first to find the value of acceleration. Then, ma sub x is equals to the forces on this plane, which are the force due to the weight multiplied by sine theta plus negative of the friction force. Negative since it's opposite the weight that is pulling it down. Expounding, we have mg sine theta minus the formula for friction force, which is the product of coefficient and the normal force. We already have the value of normal force, which is mg cosine theta. Simplifying, we have a sub x is equals to g sine theta minus coefficient multiplied by g and cosine theta. Inserting the given values, we have a sub x equals to the acceleration due to gravity, which is 10 meter per second squared for this problem, given the angle of inclination, which is 30 degrees, the coefficient of friction, 1 over 2 square root of 3, the acceleration due to gravity, and cosine 30 degrees. Solving this equation, the acceleration of the car this direction is 2.5 meter per second squared. Now we have the value of the acceleration of the car. We will use this kinematic equation to get the final velocity, which is v sub x squared is equals to v sub naught x squared plus 2 multiplied by the acceleration and the distance covered. Assuming at the top of the incline, x sub naught is equals to 0. And let us first convert the given initial velocity, that is 1.6 km per hour, to meter per second. This is 6 meter per second. Now, we all have the data that we need. So let's solve the equation. Getting the square root of both sides, we have v sub x equals to square root of sub naught x squared plus 2a sub x multiplied by x, which this is just equal to 6 meter per second quantity squared plus 2 multiplied by acceleration 2.5 meter per second squared, and then the length of the inclined road, which is 12.8 meters. Solving this equation, then the final velocity is indeed 10 meter per second. And when we convert it to kilometer per hour, this is indeed 36 kilometer per